Welcome to this video on R&D in 5G networks using NetSim. The motivation for NetSim stems from the fact that network engineers and researchers lack the requisite tools for simulating end-to-end 5G networks. There are a few link-level simulators, but these link-level simulators can only simulate a single file link between a transmitter and a receiver, and that too for a short period of time. Hence, they can't be used for end-to-end modeling of the network from the UV to a remote server. And finally, they only model the file layer and they do not allow for modeling of the entire TCP/IP protocol stack. NetSim is a packet level simulator for simulating the performance of end-to-end applications over various transport technologies. NetSim can scale to simulating networks with hundreds of end systems. A brief background on our company. We are a privately owned software company and have been building NetSim since 2005. Over the past 15 plus years, NetSim has become one of the most trusted names in the field of network modeling, network simulation, and emulation. Now for a brief overview of NetSim. NetSim is an end-to-end, full-stack, packet-level network simulator and emulator. End-to-end means simulation would be carried out from a remote server all the way to the UV. The simulator is a test bed whereby performance analysis and research can be carried out. It saves the time and cost involved in building out physical infrastructure. It comes with an easy-to-use GUI. Network scenarios can be created by simply dragging and dropping devices. There is no need to write any scripts. Again, for the output, NetSim provides a results dashboard available in tabular and graphical format with various metrics such as throughput, delay, errors, etc. The 5G protocol source C code is provided along with, which can be modified by researchers to write their own algorithms and protocols. The primary users of NetSim's 5G library are mobile network operators, regulators, equipment manufacturers, universities, and research institutions. We now move on to a brief overview of the 5G NR library in NetSim. As I have already stated, NetSim supports full-stack, end-to-end, packet-level simulation of 5G NR networks. It relies on abstract models for RF propagation and PHY performance. And some of our customers use a combination of a system level simulator or a packet level simulator and a link level simulator or an RF planning tool. Both standalone and non-standalone deployment architectures are supported. The 5G core in NetSim comprises of the AMF, SMF and UPF. In the RAN, there is support for FR1, which is the sub 6 GHz band, and FR2, which is the 24 to 54 GHz bands across all carrier widths from 10 MHz to 400 MHz. In FR1, the numerology supported is 0, 1 and 2, while in FR2 it is 2 and 3, thereby supporting subcarrier spacing from 15 to 120 kHz. In the PHY, the link adapts to change the MCS based on CQI, which in turn depends on SNR. The PHY layer modulations supported are BPSK, QPSK, 16 QAM, 64 QAM and 256 QAM. Other G-Node B properties supported are TDD and FDD bands, DLUL ratios and carrier aggregation. At the MAC, the schedulers are proportional fair, round robin, max throughput and strictly fair. There is also support for mobility and handover. To configure traffic flow over the network, NetSim allows users to set applications such as voice, video, FTP, email, HTTP, etc. What you see here is the network design window. On the left are GNB and UVs and a building to differentiate between indoor and outdoor propagation. In the center is the 5G core, and on the right is the internet, which then connects to remote servers via routers and switches. The results of a simulation run are presented in a unified dashboard for convenient analysis. Graphical plots comprises of application throughputs, link throughputs, buffer occupancy, and TCP congestion windows. The tabular presentation includes end-to-end delays, jitters, errors, packets generated, packets received, packets collided, route tables, TCP ACKs, retransmissions, etc. Results are organized per interface, per device, per application, and per link. In addition, summary metrics are aggregated and presented system-wide, that is at a network level. Information in the trace files contain individual packet flow and individual event execution. Protocol log files record a multitude of information pertaining to protocol operation necessary for in-depth analysis and debugging. NetSim provides the feature to play and record animations for the user. Packet animation enables users to watch traffic flow through the network for in-depth visualization and analysis. NetSim also outputs trace files. Users can log parameters of choice for each packet and for each event in the trace files. The files are written in a tab-ordered format, allowing for easy import into spreadsheet softwares like Excel. Then, using Excel's inbuilt filters and pivot table functions, users can analyze protocol internals and debug custom code that they may have developed. NetSim ships with protocol source codes which users can modify to write their own algorithms. The codes are written in C. We now go into the details of the RAN implementation in NetSim. NetSim supports numerology 0 through 3 in FR1 and FR2. All the FR1 and FR2 bands are supported. The common bands simulated in NetSim by network operators are the N78, which is a 3.5 GHz mid-band or C-band, the N258, 26 GHz millimeter wave band, and the N261, 39 GHz high band. NetSim carrier aggregation supports up to 16 bands in DL and in UL. The radio measurements that can be logged are SNR, RSSI, path loss, shadow fading loss, beamforming gain, CQI, and MCS. Coming to MIMO, the layer count supported is equal to minimum of the TX antenna count or the RX antenna count. G-Node B antenna count supported are 1, 2, 4, 8, 16, 32, 64, and 128, while the UE antenna count supported is 1, 2, 4, 8, and 16. NetSim also provides the ability to input path loss from a third-party tool like MATLAB or from field data. Now a quick look at the path loss models in NetSim. All the models are based on the standard 3GPP-TR 38.900. This covers different environments like rural and urban, UE positions such as line of sight and non-line of sight. The models also differentiate between outdoor and indoor propagation, as well as outdoor to indoor penetration losses. As you can see, NetSim comes with a number of pre-built examples. These include how path loss varies with distance for rural, urban, indoor and outdoor settings. Also related is how throughput varies with distance in FR1 and FR2 bands. Then an example on MAC scheduling and numerologies. Then we have examples on handover, peak throughput, and link budget analysis for different bands. There is also a real-world example involving a RAN running DL and UL applications involving phones, cameras, and sensors. And finally, an example on how UE movement away from the G-Node B impacts throughput. 3 white papers on NetSim are available on our website in the link given. Thank you for watching this video. Write to us at sales@tetcos.com for more information on NetSim.